Hello everybody. In this lesson we are going to start exercise 4.4 where we will be learning about HCF. HCF is also known as the highest common factor or the greatest common divisor or GCD. Now what is this highest common factor? Let us consider two numbers 10 and 14. Now let us write down all the factors of this number. 1 into 1, 2 is a factor, that means 10 is divisible by 2, 1, 2, 5 and 10. These are the factors of 10. And what are the factors of 14? 1, 2, 7 and 14. Now let us see which are the common factors. This is common and this one is also common. Out of these two, which is the highest? 2 is the highest. So therefore the GCD will be 2. This is example 1. Let us take another example. (24) and 42. 24, what are the factors of 24? 1, 2, 3, 4, 6, 8, 12 and 24. And that of 42 are 1, 2, 3. We are using all the divisibility rules, or you can do it like the way we did it earlier. 1 into 42, 2 into 21, 3 into 14. Then you will have 4 is not a factor. Then you will have 6, isn't it? You will have 6 into 7 and then 7 into 6. So what are the factors? 1, 2, 3, 6, 7, 14, 21, 42. 7, 14, 21, 42. Now let us find out the common factors. 1 is a common factor, 2 is a common factor, 3 is a common factor, 6 is there in both, 8 is not there, 12, 21, 42. So what are the common factors? The common factors are 1, 2, 3 and 6. And which is the maximum, which is the greatest? 6. So my GCD or HCF is equals to 6. This is the meaning of greatest common divisor or highest common factor. Now in order to find the HCF of two numbers or two or more numbers, it can be any there can be any number in the group. There are two methods. One is called the prime factorization method. And the other one is the division method. Let us start with the prime factorization method. For this we will take question number 1 from exercise 4.4. Question number 1, subpart 1. You have to find out the HCF of 28 and 56. So let us find out the prime factorization of 28 first. So in order to find out the prime factorization of a number, we will always divide by a prime number. 2 14s are 2 7s are 14, 7 1s are 7. So when we have reached 1, we stop dividing. Then 56, again we will start with 2 because it's an even number. We will always try with the smallest number first. So we always start from 2, and if it is divisible by 2, then we divide it by 2. Otherwise we move forward one by one. So 2 2s are 4, carry 1, 2 8s are 16. If it is not divisible, then we will not use that prime number. 2 14s are 14 7s are 7 1s are. So we will write it in this way, little spaced out, and 56 can be written as 2 into 2 into 2 into 7. So now let us see how many prime factors are common. Here this one and this is common, again another 2 is common, and 1 7 is common. So the HCF will be the product of these common prime factors. So how many times have I got common? 2 2 7. Okay, so 2 into 2 into 7, which is equals to 4 into 7, which is 28 is the answer. Okay, let us do question number 1 subpart 3. In this one we have been given 3 numbers, 105, 140 and 175. So let us find the prime factorization of all of them. Now see here, we will start with 2, but we are going to try with 2 first. So this is not an even number, so we will not divide by 2. Then we try with 3. How to see whether it's divisible by 3? See, 1 plus 5 is 6 and 6 is divisible by 3, so I can use 3. So 3 3s are 9, carry 1, 3 5s are 15. Now see, it ends with a 5, so obviously it will be divisible by 5. 5 7s are 35. 7 is a prime number, so I have to use 7. Then we have 140. 140 we can start with 2 because it's an even number. So 2 7s are 14 and a 0. 2 3s are 6, 35. So again 5 7s are 7 1s are. And then 175, straight away I can start with 5. See, it is not divisible by 2 because it does not end with an even number. It is not divisible by 3 because the sum of the digits is not a multiple of 3. See, 5 plus 7 is 12, 12 and 1 13. 13 is not divisible by 3, so we cannot use 3. It is not divisible by 4 also, so my first choice will be 5. So 5 3s are 15, carry 2, 5 5s are 35. So again 5 7s are 7 1s are. So let me write down all the prime factorizations. 3 into 5 into 7. I will try to arrange the prime factors and write so that it is easy for me to find out the common factors. And 175 can be written as 5 into 5 into 7. So see, this one has a 3, but is 3 in all of them, in both of them? No. Now let's see 5. See, 5 is here, once it is here, once here and once here. So I have got 1 5 common in all. Then you see 7, 1 7 here, 1 7 here, 1 7 here. So 1 7 also I have got. Now see here, I have another 5 over here, but it is not there in this, neither in this. So I'm not getting another 5 common in all 3 of them. So I don't have anything else common. So my answer is 35. This another way some girls prefer writing it down is in this way: 3 into 5 into 7, then 140. You have 2 into 2, so there is no 2 over here, so you write 2 outside. 5 below 5 and a 7 below 7. And 175 can be written as 5 into 7 into 5. So this is common and this is common. Okay, whichever you feel is easy for you, you go for that method. So this was the prime factorization method. Now we will do the division method. For doing the division method, we will take up question number 2 from question exercise 4.4. Exercise 4.4, question number 2. Subpart 1, we'll start with subpart 1. Okay, let us start with 2 and then we'll move on to 1. You have to find the HCF of 20, 64 and 104 using the division method. Now let's see. Now when there is a group of 3 numbers, we will first take the smallest 2 of them and I will divide the larger of them with the smaller one. So in this group of 3 numbers, the smaller ones are 20 and 64 and I am dividing 64 by 20. So let us see what is the coefficient and what is the remainder. 20 3s is 60, right? 20 ones are 20. We will follow the 2 times table. See, 2 ones are 2. So 20 into 1 will be 20. 2 into 2 is 4. 20 into 2 will be 40. So in this way, 2 into 3 is 6. So 20 into 3 will be 60. So I will give here 3s are 60. Now please pay attention. After this subtraction, since the remainder is not 0, I have to continue division. Now who will come here? This one will come here. So 20 is coming here. Okay. Who comes here? The previous divisor comes inside. This is the remainder. Now I will forget about this and do this division. 4 5s are 20. Remainder is 0. So we stop. So this last divisor, okay, is the HCF of these 2 numbers. So therefore HCF of 20 and 64 is equals to what? 4. Now what I am going to do is I am going to divide the third number with this HCF in this method until and unless we get a 0 remainder. So 4 2s are 8, 24 and 4 6s are 24. So I get a 0 remainder. So the last divisor is 4. So here also then the HCF is equals to 4. This is my answer. 198 and 429. This is an example from 2 subpart 1. 198 and 429. So let us find the prime factorization of each one of them. 198, 2s are 2 9s are 18, 2 9s are 18, 3s are 33s are 99, again 3 11s are 11 is a prime number, so 1s are 429. Now see, it is not divisible by 2 because it is not ending with an even number. Let us try with 3. Let us find the sum. 4 plus 2 6, 6 plus 5 15, 6 plus 9 15, so 3. 3 1s are 3, 3 4s are 12, 3 3s are 9. Then it will go with 11, right? 11 1s are 11, 11 3s are 13, so 13 1s are 13. So 198 is 2 into 3 into 3 into 11, and 429 is 3 into 11 into 13. So what are we getting? 1 3 common and 1 11 common. So my HCF will be 3 into 11, which is 33. is my answer. Okay. Now I will do this using the division method as required in the question. So I am going to divide the larger number with the smaller number. So in the rough column I can try out all the multiples. So 198 into 2 is 2 8s are 16, 2 9s are 18 and 1 9, and 2 1s are 12 is 3. So 2s are 396. 9 minus 6 is 3 and 12 minus 9 is 3. So I get 198 coming inside because the remainder is not 0. So now let's see 33. Now 33, this table of 33 is very simple. 1s are 33. 33 into 2 will be 66 in this way. So since we have a 8 over here, I will guess and find out into 6. We will see that I will get, see, 6 3s are 18, again 6 3s are 18 and 1 198. So 6 are 198 and we get a 0 remainder. So since we have got a 0 remainder, which is the last divisor, 33. So my HCF will be 33. Okay. So in the prime factorization method as well as the division method, we have got the same answer. Next we will do question number 4 from exercise 4.4. Question number 4. Find the greatest number which can divide 257 and 329 so as to leave a remainder 5 in each case. So basically you have to first find out the HCF of 257 and 329. I will read the question once more. They are asking you for a number which divides by 257 and 322 and leave a remainder of 5 in each case. That means 5 is extra in both of them. So let us find out the HCF of these two numbers. Okay, now we will do question number 4 from exercise 4.4. Let us read the question. Find the greatest number which can divide 257 and 329 so as to leave a remainder of 5 in each case. So you have to find a number n which is a factor of both 257 and 329, and in each case it leaves a remainder of 5. So that means these are not the actual multiples of the required number. They have 5 extra in each one of them. So what we are going to do first is that we are going to subtract that extra 5 from both the numbers. So what do we write? Since 257 and 329 leaves a remainder of 5, the multiples are 257 minus 5, which is equals to 252, and 329 minus 5, which is 324. So actually you have to find out the HCF of these two numbers. So now HCF of 252 and 324 is, now you can use any method that you are comfortable in. So see, when both the numbers are big, division method will be the faster process. So 252. Now 252, you can understand that if it is if you multiply this with 2, you will get something in 400. So obviously it is ones. 252. 4 minus 2 is 2 and 12 minus 5 is 7. 252. So you can do it in the rough column. Now see, here we have a 7, and when we multiply 7 into 3, we get something in the 20s. So I will first guess with 3. So 3 2s are 6, 3 7s are 21. Okay, we still have space, so I will go to not 8, I will go to 4. So 6, okay. 4 will be 4 2s are 8 and 4 7s are 28. So it's going beyond 252, so 3 was my correct choice. So 3 is a 216. So if you subtract this, what do you get? This will become 4. 12 minus 6 is 6. 4 minus 1 is 3. Now again the remainder is not 0, so 72 will come here, and 36 2s are 72, and we get a 0 remainder. So the HCF is the last divisor. Who is the last? Which one is the last divisor? 36. So therefore the HCF is equals to 36, and the required number is 36. Okay. Let us do question number 5. It is similar to question number 4, but the remainders are different in this case. Question number 5. They have asked you to find out the largest number. Whenever they have asked you to find the largest number, that means you have to find out the HCF. Largest number that will divide 623, 729 and 841, leaving a remainder of 3, 9 and 1 in each case. So you have the GCD or HCF as n, and these numbers are actually not the exact multiples. They are leaving a remainder of 3, 9 and 1 respectively. So these numbers are extra, so we have to first find out the multiples of n. So let us subtract 3 from 623, 9 from 729 and 1 from 841. So the multiples of the required number are required number are 623 minus 3, which is 620. This is the first one. 729 minus 9, this is 720, and 841 minus 1, which is 840. So you have to find out the HCF of these three numbers. Thus the required number is the HCF of 620, 720 and 840. So we have three numbers. We'll first take these two smaller ones. Okay, 621s are 620. Whenever large numbers, all are large numbers, go for the division method. It is always faster because large numbers will have a very long prime factorization that will take a lot of time. So 0, 0, 1. 620. 6 are 600. Remainder 20. 100 comes down. 5s are 100. So 0 remainder. So what I'm going to do is I'm going to use the HCF of these two numbers to divide the third number. 840 divided by this one, right? The last divisor, 20. So 20 4s are 80. 0. 22s are 40. So here the division is 0. So this is the last divisor. Therefore, HCF is equals to 20, or the required number is equals to 20. This is your answer. Let us do question number 6. Exercise 4.4, question number 6. Let us read the question. Meenu purchases 2 bags of rice of weights 75 kg and 69 kg. Find the maximum value of weight which can measure the weight of the rice exact number of times. So now they're asking the maximum weight weight means when they measure on that beam balance, one side they give the goods or whatever you are buying, and the other side they give that iron weights. So they're asking which is the maximum weight that can be used so that both can be measured exact number of times, using exact number of times. So here obviously you have to find out the HCF of 75 and 69. So let's write the statements first. So the first bag, we have 2 bags of rice of weight 75 kg and 69. So we'll write weights of rice bags is equals to 75 kg and 69 kg. Now let us find out the HCF of 75 and 69. So 75 divided by 69. 69 ones are 69. 15 minus 9 is 6. 69. Okay, 6 ones are 6. Then 9 comes down. Again 6 ones are 6. Remainder 3. Again this 6 comes down over here. 3 twos are 6. So remainder 0. So what is the HCF? HCF is equals to 3. Therefore, the greatest weight value that can measure both bags exact number of times by exact number. Exact means completely that okay, I'm explaining. Wait. Exact number of times is equals to 3 kg. So in both the cases you will see, if you divide 75 by 3, what do you get? 3 2s are 6, 3 5s are 15. So 25 times. So this 3 kg weight you have to use 25 times for 75, and for 69 if you divide by 3, this is 23, this will be 23 times. So there is no remainder in any of the cases. So that is the meaning of exact number of times. So your answer is 3 kg. With this we have come to the end of exercise 4.4.